Last week, we said, do you guys know how to convert this to rectangular equation that says 4 sine of theta? Do you know how to convert this to rectangular equations?
Yeah.
What do you do?
What would you do?
How do you convert this to rectangular equations?
Hold on. Sine of its opposite, so y over r.
Oh, I didn't need paper. I have paper soon. What else? Oh, you want to convert it?
Sine of theta equals y over r, right? Wait, that doesn't make sense. Trevor, you're a genius. Can you help me out with this? Can you help me out with this?
Oh, we have something similar to this. Isn't it this one? Yeah. See, good learning.
What's this about C?
How do I convert this to rectangular equation? Do you guys know how? Multiply both sides by r, good. Then you get r squared equal to 4r sine theta. We had 2 birds, 1 stone because both sides can be rectangular now. X squared plus y squared equal to 4y now. Because r sine theta is y, right? So x squared plus y squared minus 4y is equal to 0. Now I can complete the square. So it'd be -2 squared, that's equal to 4. So I'm going to plus 4 on here. And plus 4 on here. So it's going to be x squared plus y minus 2 squared is equal to 4. So it'll be 0, comma 2 is my center. My circle is going to have a radius of 2. Do you guys remember this?
Can you make a screen read?
Yeah, of course. My bad.
Oh my gosh, I'm doing it.
This is a pre-calc.
Objection, Your Honor. I think most of our pre-calc teachers weren't that good. Or
Yes.
Well, you had the Craig, right?
I had Craig, but he gave up because it was his last year.
That's so sad.
Yeah.
I hate when teacher give up. It really pissed me off.
So I don't really have the basis.
I would never give up on any child at any moment if I'm getting a teacher. I'd rather quit first. Because if you're gonna give up, why you collect the paycheck and still ruin the education of the future of the kids? That doesn't make sense. For me, that's a crime. That's no offense, that's a crime. I mean, you can suck at teaching, but you should not give up on teaching the kids. At least you put effort in there. Have more respect for people who suck.
Let's get on there.
Bye.
Thank you, Miss Shea.
You cannot talk.
Yeah, you can.
I'm not talking about you guys. I'm talking about teachers.
Yeah.
City identified. No.
Okay. So what we're gonna do is we're gonna figure out how to draw a flower. I'm gonna show you what is flower here. So this is a r equal to 4 sine theta. Now, if you draw an A right here, and you're gonna see this flower is forming. Are you guys seeing this?
What? That didn't really change it.
Oh, damn, it looks like this spiral.
Have you ever heard of gyroscope? Oh, spirograph? Yeah, I know what you're talking about. I have one of those.
So much.
So I'm gonna show you what happened. Instead of A, I'm not gonna do A. I'm gonna just do 1. So what happened if it's 1? It's gonna give you 1 petals. So all the odd number is gonna give you same petals. So for example, 3 is gonna give you 3 petals.
Yo.
When it's 5, it's gonna give you 5 petals.
Why is it narrowing down now?
When it's 7, it's gonna give you what? 7 petals.
It overlaps that way.
No,
no, when you
they
do it.
need spaces.
So
What
are
about
you?
even number?
How about even number? What do you think is even number?
2.
No, it's gonna be fucking different. Yeah.
Yeah, it has to look different.
Yeah, it's gonna look.
Oh, thicker.
It does. So
It's
we
gonna
have
be
to do
double amount of paddles. 4.
4 times 4.
4 times 2.
is 8. Yeah.
And you know, 6.
Well, hold on. So the odd number does exactly how many petals there are, but like the
Even number
number's
is gonna give
double?
you double.
Yeah, it's pretty wacky.
Okay, questions?
Good stuff.
Now we're gonna draw one. I'm surprised Zach is here. I feel love here today. Zach.
10 points at Gryffindor.
Exactly. Zach, you didn't go to the beach with the rest of them?
No.
They went to the beach.
I think,
They have to. Where else do they will go?
they might have-
Yeah, they can also go like go. I don't know. Go to.
Oh,
Whoa!
They can also go to Burger Pie. It's like right there.
How did they go to
Burger
Burger
Pie.
Pie?
It'd be funny. So.
Can I go to the beach next to play next year?
Yeah, you sure.
Okay.
As you can tell, if I have voice crack, my voice will be.
All right, so so what we're gonna do? We're gonna draw this graph. R equal to 4 sine of 2 theta.
Monsieur, I need my compass. Hold on.
No, you don't need a compass. No, you just had to help me here. It's actually very, very cool. And you guys gonna tell me where do I need to plug in the values. So first I'm gonna draw a T chart and I'm gonna do a theta and R. So it's like X and Y is the input and output. And I'm gonna plug in bunch value that you know of. And you're gonna tell me what its value is, and you're gonna tell me where to plug in. So somebody need to go up there and point out where you need to plug in. So
Theta.
okay,
So
so
are we using rectangular coordinates or like that's still polar?
we're using polar. So 0. Shh. We're gonna use 0. 0, what am I gonna get if I plug in theta 0? 0. Good job. So 0, 0, it's gonna be right here.
Student should now be back. Eight.
Zach, you feel like genius today?
feeling smart today.
Feeling smart today?
He is smart.
All right. So the next value, I want you to plug in pi over 6. What do you think pi over 6 is going to be?
Pi over 3, so sine of pi over 3. Square root of 3 over 2 times 4. It's 2 square root of 3.
2 square root of 3. Okay, do you know what the square root of 3 is?
1.4.
1.7.
No, sorry, that's square root of 2.
1.7, so it'd be 3.4. No, 3.4-ish. So where's 3.4-ish? Xavier, can you go point out my pi over 6 and 3.4? Where's that?
Yes. Well, I would. It was obviously along this line, right?
It's obvious on this line. Good job.
Okay. Let's see. 1, 2, 3.4. It's around here.
Okay, that's actually pretty good. That's pretty good. So 1, 2,
Oh wait, sorry.
3.
A little less than. Sorry, a little less than half. So right here.
3.4.
Yeah.
Do you guys see that?
Thank you.
Is that okay?
That makes sense.
Okay, let's go plug in pi over 4.
Would you mind giving us like on the test when you print it out? Could you also print out like this circle?
Yeah.
Okay.
I won't ask you to graph polar function, no, but I would. Okay, so pi over 4, what do you think is?
Square root of 2 times 4, which is 4 square root of 2.
Wait, where did the square root of 2?
Oh.
It's just okay. Pi over 4
Is-
times 2. Make
Oh,
pi over
I didn't multiply by 2. I did sine of pi over 4. I'm sorry. It's sine of pi, which is 1, so it'd be 4.
4, good. So where will 4 be at? Nico pointed out, where's 4 and pi over 4 at?
You know this.
You got this.
2.
Yeah, pi over 4. Where's pi over 4 and 4 at?
I feel like I'm
The
like-
middle one.
Is the middle one, good.
And then it's 4, so we go 1, 2, 3, 4.
Perfect. It's gonna be 4 right here.
Cool, that's.
Does that make sense? Because
That was pi over 3.
No, because that's pi over 6, pi over 3, and pi over 4 would be in the middle.
Yeah.
They just don't have the line.
Ah, okay. Yeah.
Okay, let's go to the next one. What is pi over 3?
It's a great question.
Be 2, 5.
Come on, anything past pi over 2 is a little cursed.
Here. Okay.
A little curse.
Yeah. Come on, like, come on.
2 pi over 6, 2 pi over 6, 4 pi over 6, 2 pi over 6.
Pi over-
What's that one?
2 pi over 3 is the square root of 3 over 2. Oh, it's the same thing as pi over 6, is it not? So like 2 square root of 3?
Yeah.
Okay, so what would it be at?
Yeah, Maria.
Maria, go. Where would it be at?
Bye.
Let's go. Class participation for the win.
Yay. Wait, I swear.
Well, we're not drawing this on our paper, right?
It's be right here.
Come on.
You got it?
I'm just drawing,
You got it right?
I'm just drawing the table.
Okay, so if you see this is gonna be your first paddle.
Whoa.
Reading. It's funny. Come on, guys.
I
You guys
I
did
think I need that memory.
Do you guys see that?
Yeah.
Okay, let's go do more. What do you think? Which paddles do you think go next?
He's gonna hit us if we say pi over 2.
Which paddle do you think is gonna be on first? This first paddle is on first quadrant. Where do you think the second paddle is gonna be located?
Second quadrant?
And then third and fourth, like reflective, right? Like we.
We.
Yeah.
That's like sound effect. We. He's like speaking French. The graph is speaking French.
It is.
Wait,
Bonjour, bonjour, bonjour.
He said that the 2 makes it double. So
Yeah.
it would be 4 petals. So it would have to be 4 petals like that.
Yeah, but which paddle is gonna go first?
it's going counterclockwise, is it not?
We're gonna see. Okay, so what happened if I plug in pi over 2?
Pi over 2 it would turn into 7 pi. So just 4, right? It would be 4, right? Oh no.
It'd
And
be
here-
0.
Sine of pi over 2 is 1. Sorry, sine of, but it's sine of pi, obviously. Oh. I keep
Okay,
thinking multiply by
next one. 2 pi over 3.
I hate these numbers.
Okay, 4 pi over 3 is greater than pi.
5 over 6, 2 pi over 6, 3 pi
Oh
over
my gosh, is this in the third quadrant?
6 pi over 6.
I don't know. You guys gotta figure out.
4 pi over 4 pi over 3 is basically pi over- is it a negative 2 root 3?
-2 root 3. Yep, that's good. No, where is that, Xavier?
Bottom. Oh, do you want to go up? and, like,
Yeah,
up?
go point out where's that.
Yes, I definitely know where 4 pi over 3 is. Hold on.
4 pi. It's pi. 2 pi over 3. No, 4 pi.
Oh yeah, you're right. 2 pi over 3. Sorry. Why am I being stupid?
3 pi over 6.
It's not here, right? No, it is here.
It is right there, yeah.
It's along here and then negative. So it's in the fourth quadrant.
So it is going down.
So- Wait, it'd be negative 3.4, right? So 1, 2, 3. It'd be around here.
Very good, very good. So it's gonna be at 3.141, 2, 3, 3.4. It's gonna
Okay,
be
because it's negative, you have to flip it like immediately. Like,
because it's in this line, right? But it's a negative, so this will be positive direction, but negative is gonna go this way.
I thought about the physics for this.
Huh?
Why?
It's counterclockwise. It means
It's positive.
positive.
Okay, what happened the next one? That's what happened is 3 pi over 4.
I hate these numbers.
Well, it's gonna be sine of what? 3 pi over 2. Sine of 3 pi over 2 is what?
Sine of 3 pi over 2. That's negative 1, right?
Mm-hmm. And that's just gonna be -4. Does that make sense?
Yeah.
Which quadrant's the neg?
That's just straight down. It's not really a quad, isn't it? In between 3. Oh, sorry. We're in 3 pi over 4.
It'll be right here.
Hold on.
Yeah, so it's sort of like.
Do you see that it's the second paddle?
Oh, yeah, that makes sense.
Yeah, so the third one will be the other one.
The other one is gonna be which quadrant?
I want to say third quadrant.
Third quadrant's right.
Okay.
Yeah. So it's gonna be the way that they are kind of interesting. They go by this, like this. Oh no, sorry, it's the other way. Sorry, it's like this. It actually follows flow.
How do you get that third point?
What?
What's that third point? Is that just pi?
So eventually it will be like this.
Yeah.
That's kind of cool. Okay, if you have a block, 12, 1, 2, 3, that's not what it looks like. Yeah. So it's going.
Yes. Clockwise.
Am I going too fast? It's okay. So here's the thing. You guys have to understand this, and that's why this is a pre-calc lesson, but it's important. But later we're gonna ask you to find area within the pedals.
No.
So no, you won't cry. Then that way you'll know like which quadrant, which value to which value. So let's just say if I go in from 0 to 0 to pi, then it's actually those two pedal on the right hand side, and those are the things that you need to know. And so it's actually pretty intuitive. Once you start understanding those, then you can understand, okay, which area I'm looking at. The problem is people don't understand which area they're looking at, and that's why most of people they have problems.
Lucian,
Yes.
so this is going clockwise for like an even coefficient for that theta. What if it's like an odd? Is it still going clockwise?
I don't know if like clockwise and counterclockwise it matter, but what matter is actually axis of symmetries. Okay, so there are three types of symmetry here. According to pre-calc, they are symmetry to polar axis, they are symmetry to theta equal to pi over 2, and they are symmetry to the pole. So there are three types of symmetries. So I'm going to write it down for you. There are three types of symmetry. One is polar axis, which is symmetries. There is three types of symmetry. Polar axis. Second, they are the line theta is equal to pi over 2. The third one is the pole. Now, for this one, we completely doesn't make sense. But for rectangular, I would say this one is the x-axis. And this one is a y-axis, which is pi over 2 is straight line.
Polar axis and the pole are two different things.
Yeah. Pole is origin. You know, remember that y equal to xq graph is symmetry to the origin. And so here is symmetry to the pole.
Want to slay the flower?
Okay, so this, do you understand what I'm saying?
This makes sense. Yeah.
Okay, so polar axis is x-axis. The line of equal to theta equal to pi over 2, same as y-axis. The pole is like origin.
That's his origin.
The pole. Okay, hold on. You know the Earth when you're looking at like longitude and latitude, but like at the top, the pole. So if you think of it as like the North Pole, yeah. Just literally the
So
North Pole.
this is like America. And this is a Mexico. And stuff like
No,
that.
yeah, no, actually true.
I don't know how to draw stuff. I'm just making shit up as it goes.
And here's Russia, and
Russia and America is actually super close. Or in Alaska side.
Yeah.
at least.
oh yeah, for sure. You know there used to be a land bridge between Alaska and Russia.
They do?
There used to be a land bridge between Alaska
And they
uh,
break it? Who
what?
destroyed it?
What?
Who destroyed it?
It wasn't destroyed; it was submerged from global warming.
Oh really?
Yeah, that's how you know how they're like Native Americans.
Uh,
It's theorized that they walked over the land bridge, like thousands of years ago.
land bridge is the actual bridge or the land?
No, it's a bridge of land.
Uh,
So you know how the North America and South America are connected by a small little like land bridge? Well, like they're just connected like naturally.
yeah, that's why they say a lot of like Indian here in Aboriginal Indian.
Yes,
They
that's what I'm
have
saying.
they are look like Asian in some way.
Yes.
Some people look at Asian. And because Asian kind of migrate through there.
You're like,
Exactly. That's how they migrated.
Oh, is it? I don't
Yeah.
know. Possible. Okay. So there are three type things. For sometimes my the other calc BC teacher, not Cooper, but the other one, the friend I used to work with, his name's Roy. So Roy says to me is that you gotta make sure student understand the symmetries. So how do you understand symmetries? Do you understand like when you got even and odd functions, like y equal to x squared, what is that symmetry of?
No, on the y-axis, right?
Yeah, so y equal to x squared. And how do you know it's symmetry to y-axis?
Yeah.
Well, no, it's to replace this x with negative x. And if you go back to the equation, that's the symmetry to y-axis. Now, y equal to x cubed, you replace that negative x to the cube, so y is equal to negative x cubed. This is called symmetry to origin.
I think.
And this is symmetry to y-axis.
Mr. Ye,
Yeah.
if you is symmetry to origin also called rotational symmetry?
I have no idea. That I don't know. I don't want to tell you stuff I don't know.
find symmetry to the x-axis.
Symmetry to x-axis, I mean you can, but there's almost no point. Usually you'll study if they are even function, their even function is symmetry to y-axis. If they are odd function, they are symmetry to origin. But symmetry to you had to replace the y. Y with a negative y and see what happened. But usually you don't have to do that. So there are two types of symmetry for us in algebra 2, right? In algebra 2, they have this is even functions. This is the odd functions. If it's odd function, you plug in negative x, go back to opposite of the original function, then that's called symmetry to origin. Now, for as here goes, you're gonna replace the data with negative data. And if you go back to same as before, then that's called a symmetry to polar axis. Okay. Now this one you replace. This one you're gonna be replace data with negative data and r with negative r. If you go back to before, that's gonna be symmetry to the line of pi over 2. So this one is going to be replaced
It's symmetry to
r
go back-
with negative r.
symmetry to go back to what it was.
Yeah. So I want you to think about what this one's symmetry of. That just say if I have r equal to 4 sine of 2 theta, I'm going to replace the negative data. So r equal to 4 sine of 2 negative theta. That's equal to 4 sine of negative 2 theta, right? Now, since this one is an odd function, this one is going to give you negative 4 sine of 2 theta. So it didn't go back to original, so it's not axis, it's not symmetry to y. It's not symmetry to y equal to x or the polar axes.
Wait, where's the R? Oh, did he make the?
It's not symmetry to x-axis.
Oh, it's not symmetry. Yeah, that makes sense.
Yeah. Even though this graph is, but it's not, first, it did not happen, like very beginning. So you know this is not symmetry to polar axis, which is the x-axis. But according to the graph, it looks like it. But you're going to see what happened. It's not. Okay. Now, for the second one, r equal to 4 sine of 2 theta. What do we say to replace what?
Theta with negative theta and
which is, yeah, this one's going to be negative r for sine of 2 times the negative theta, right? So that's going to be negative r equal to negative 4 sine of 2 theta. And then if you get rid of both sides by negative sign, guess what? They are symmetry to pi over 2. Guess what? If they are symmetry to pi over 2, can I just copy this? Do you see what I'm saying or no?
Yeah, you can do that.
And do I just... and then you can just copy it because you have a symmetry line here. Because you can just mirror image this. You get that so far? So there are 3 types of symmetry. You can always try what a symmetry of. If you figure out what a symmetry of, according to the other BC Calc, he's teaching for 30 years. And he says, always have students figure out what a symmetry of. If they can figure out, they can figure out a lot of things. So tomorrow we're going to work on what is the slope at this particular point. Or what is slope at this point.
Wait.
And on Friday and Thursday, we're going to find out the area of this. Okay, we're going to find out these areas. Okay? On Wednesday is SAT. I don't know what am I proctoring.
Oh, period. Yes. I will make class.
You're gonna the SAT anyway.
No, but like, I will make how lesson.
Huh?
You want to get paper back?
Maria Linden